Okay, so this video is about outputs, but first we'll show how we get there. So if we're on the main display, we click the three bars and we would choose output. So we're just touching it to go in there. Now, outputs is where you do all your setting and set points and all that jazz. So a lot of people think it's in the sensor is where I do all that, or in the input, and that's not the case with the wall cam. Why that is because it's the thing that, like in this case a pump, we needed to say when do we want that pump to go on and off. Whereas the input, all that's going to do is say, hey, what is that input, conductivity, and what value, and what alarms do we want to go off here. Whereas in the output, we want, in this case, an inhibitor pump on relay 1, we want to tell us when that comes on and off. So one thing to do with outputs, there are lots of different types of, and I'll scroll down, there are lots and lots of different types of, I'll show you, modes. So if I scroll down these modes, and each one of these modes in here, I know I'm scrolling really fast for the video, but each one of those modes actually has a different set of parameters. So what you basically do, go into your output, you choose the relay you want to monitor and correct, and then what you need to do is go into settings and choose what's the mode I want for that particular relay, or in this case that particular pump. So I'm going to scroll down, and in this one it's an inhibitor, so I want it to just go on and off. So I will choose on and off. Okay, and then what that does is that gives me all the parameters to now at what stage do I put the set point, what's the deadband, in other words what's the gap before it goes, when it goes up it turns off, when it comes down it turns on. So what is the size of that gap or deadband? Duty cycle period, basically what that is saying is it's how long you can go. If we were on a clock, you can go around like this, and you can go, hey, on this duty cycle, how long is that? Is that a quick one, like 10 seconds, or is it 5 minutes and it takes ages? And what that's saying is every time that cycle goes round, in which you can change the size of it, in other words the speed of it, 10 seconds, 1 minute, 5 minutes to whatever, does it check the sensor before it activates the relay. So cycle period is the duration. If I go into this, so the duration in which that takes before it comes around to start again, and the duty cycle is the percent of that. So for example, am I going to have 100% of 1 minute before I do anything? Or maybe it might go, hey, if the duty cycle period was for 1 minute and I put in here 50%, what that's actually saying is, even though it's going for 1 minute, what I want it to do is I want it to do something only for 50% of that time. In other words, 30 seconds. You might ask yourself, why the heck do that? What it does is this creates really fine control. So when this is activated and going, what ends up happening is and if I put this here, every minute, oh, that's an hour, go back, whatever. Boom, there we go. What it would say here is every minute it's going to do this, but for 50% of that, or 30 seconds of that, it's going to monitor, and 30 seconds it's not. And then another minute it's going to look at it again, but 30 seconds it will actually monitor and do something, and activate a relay if it needs to, and 30 seconds it won't. And again, you can change that time period or the percentage of when it's active or not active. Really good idea, particularly for bleed valves or anywhere where you want to find control. Obviously you can delay the time that it's on, that relay. You can also delay the time that it goes off. And if all these are set to 0, that means that they just go unlimited. If I scroll one more down here, reset outputs, that's just obviously reset them. Interlock means, hey, when my set points are activated, what else do I want this relay to be interlocked with? So for example, in this particular case, we have if I can show you, we have a flow switch. And what we're saying is when the flow switch is activated, then this pump works. It's D1, digital signal 1. When the flow switch is not activated, meaning there's no flow through the cooling tower, do not activate that relay because it's obviously turned off. Let's not waste chemical. So that's what that is. Activate with channels means when this happens, make this happen. So for example, you could go, when the inhibitor pump works, can you make the biocide 1 pump work at the same time? or you could make something else turn on, like a transfer pump, because you've hooked it up to a different relay. So when you go to activate channels, you could say, hey, make these relays work at the same time as that relay. So that's what activate channels is. Hand time limit, that's saying when I do the, when I go back to here, and I press this button here, what is the limit that I want that to run for? 2 minutes, 1 minute, 10 minutes? Because some people all have different parameters when it comes to that. I get back to the outputs in here. That's what I'll get back in. That is what the hand limit is. Oopsie. There we are. Obviously, a reset, that resets it. So one thing to note too is whenever this relay is activated, relay 1, it gives you the time of how long it's been activated, which is really, really good, because you can go, hey, I know the relay's been on, but this chemical drum is still full, so there's obviously something wrong with the pump or whatever, or you can start to problem solve backwards. Whereas if that has got 0000 on it, that means, uh-oh, something wasn't set up in the controller right, because the relay hasn't been working at all. This is the input, in other words, what's controlling this relay, in this case it's conductivity, and what this here is, there's only 2 types of directions, force high, force low. What that basically means is, in this case, what we're trying to do is when the conductivity goes up, because that's what it does in a cooling tower, we want to activate it and force it back lower. So we basically, the set point will be here, and the direction that it will force is this way. Okay, and that's what that's doing. So if I go back into a bleed valve, ideally, if I can, it might not be set up in this one, but we'll check. Yeah, I'd want it force lower too here. So in other words, when the conductivity gets high, boom, I want the bleed valve to open, dump the cooling tower water that's dirty and really, really high in microsiemens till it gets down to a certain value. Could be 700, could be 400 based on your tower, that's microsiemens, and then it closes the valve. So that there means it forces it back this way. If it was forced higher, it would force it up. And why would you have that in a cooling tower? Because imagine if you wanted to create, control pH on another one of the relays with a different sensor. So now you could force it, base it, whether it's alkaline or acid, force it up or down. So that's what that's about. So in a nutshell, that's outputs. That's how you get there. That's how you change it. And of course, the last thing I didn't show you, I'll go back in there, whoopsie, which is at the very, very end, is how to change the name, which is the same as the others. You go in there, you type away, and of course, tick the box, and then that name will be there. So just last thing to remember, in summary, outputs, select the relay that you want to change, press the spanner, but do go and set the mode first for the for what you're trying to do for that relay, because that will give you all the parameters in the menu of when you select that output.